everyone, today we're going to talk about water heater maintenance, okay? We're going to talk about some in-depth water heater maintenance. Sometimes water heaters, they go neglected, okay? They go on, they don't get any maintenance. I've had several people tell me that they don't need to maintain their water heater or they don't maintain their water heater. Okay, I don't really need to know that, but for those of you who are interested in maintaining your water heater, we're going to talk about what the status quo is right now with companies and how they do their maintenance on their water heaters and what's included. Specifically to do with maintenance plans. Now, traditionally maintenance plans for water heaters, sometimes they're lumped in with the HVAC system, sometimes they're not. It depends on which company you're going with and if they offer both, okay? Water heater maintenance plans will a lot of times be anywhere from $25 to $50 or $60 per month, and what that gets you is an annual inspection. The inspection, they just come out and they do a visual inspection of it. Whether or not they check the components is kind of hit or miss inside of them. In our area, most of the time, it's just not anything that's performed. They'll do a flush on the water heater, drain it down, may or may not look inside of there. Some of the things that are missed are checking the actual voltage to the water heater, checking the resistance of the elements, opening up the system and looking at the elements and seeing if they're dirty or if they have a lot of buildup on side of them, or a lot of buildup on the elements. That can be kind of cleaned off, and if it's real bad, the element can be replaced. Checking to see if the element is grounded. Okay, these are components that should be checked. Having a properly installed and working and functioning expansion tank up on top is a big deal. All right, cathodic protection on the inside of the water heater tank is something you definitely want to keep track of and make sure that you have, as well as something to absorb thermal expansion. Those are the two things that are going to cause failure in your water heater. I've had people tell me, well, I don't need to maintain my water heater, I put it in, and then when it fails after 5 or 7 years, which is the average in this area of the lifespan of a water heater, I'll just replace it for a new one, and then I save all that money on the maintenance I didn't do, right? Okay, great. How about doing the maintenance and doubling the life of your water heater and then not spending that? I'm not talking about hiring the cheapest guy, I'm talking about hiring a reputable company, okay? Not the guy at the end of the street that drives a pickup truck that just needs to pay his rent and his beer. I'm not talking about any of that, right? With that type of logic, I can tell you I'm gonna go buy a car tomorrow and I'm not gonna change the oil for 5 years, and then I'm gonna go and I'm gonna turn it back in and trade it in on a new one, and then I'm gonna brag about all the money I didn't, or the money I saved not changing the oil. Who cares? This is for people that wanna maintain their water heaters. We're gonna go over some things that should be done and should be checked. Now, these are things you can check yourself. It's true. DIY, if you like to do it yourself, fantastic. You have questions, I'm here to help you out. All right? I don't want to work for you. If you can do the work yourself, you don't want to hire me. Don't. But you want hands off, you want someone to just come out and take care of it, we're certainly there to do it. Now, like I said, the usual cost of service plans, $25 to $50 a month. For a little bit more, you can actually get a service that includes the inspections, quarterly, thorough, comprehensive inspections, replaces maintenance parts, and also once the water heater becomes fully vetted in the program, will cover the replacements. All right, every water heater has a temperature and pressure relief valve. I'll show you that up on top. The temperature and pressure relief valve will relieve excess pressure inside of the tank if your temperature gets up to 210 degrees or the pressure gets up to 150. Now, most plumbers, I don't know, they don't know that. It also says on the tag that that's supposed to be replaced every 1 to 3 years. Nobody replaces those as well. What can happen if those fail? Just Google water heater explosion, Phoenix, Arizona. It happened over last summer. The water heater did not have the ability to relieve the pressure inside. It exploded, it leveled half of the house. If you think that's great and you want to risk it, fine. By all means, do that. However, if you're safety minded, then let's get that checked. We'll change those things out when they need to be changed out, keep the water heater running in tip-top shape. Also, another thing to factor in is as you run your water heater and you neglect it, it does start to become inefficient. Gas water heaters are extremely less efficient than these electric water heaters. And like I said, we're gonna have multiple videos on this, but this one's just gonna be aimed at electric. We're gonna go through heat pump water heaters, gas water heaters, and tankless water heaters as well, so we can show you. This is gonna be aimed at electric. So gas water heaters, they're not as efficient. You know, on your lower level, they call these builder grade water heaters. You build a home, these are what's gonna be put in. Builder grade gas water heater, not as efficient as a electric water heater. So these electric elements are submerged in the water, so 100% of that heat I'm generating is actually going into the water. The difference being gas is extremely cheap, so we can burn gas, heat the water, have 30-40% of the heat leave out through our exhaust up on the top, and it's not expensive to run. With an electric water heater, they are efficient, but remember, when that meter's spinning and these things are cranking out power, your electric bill's going up. So why not keep this running efficiently? Otherwise, year after year, the cost of operating this thing is going to go up. And it's a couple bucks at a time, and because it's a couple bucks at a time, people don't know it, they don't care about it. Well, guess what? So is a maintenance plan, right? We've got a concierge plan rolling out. We're gonna take care of maintenance, we're gonna take care of repairs, we're gonna take care of replacements, and it's just a couple bucks a day. All right, so let's start doing some inspections on this water heater. But like I said, call your plumber out if you're on a plan right now. Traditionally, you see them kind of do a visual inspection, put a hose on it, flush it, drain it, maybe not, put it back together and call it good. The anode rod, which is usually accessible from up on top of the water heater, is not always checked. I get complaints all the time. I can't get it out. I don't know how to get it out. I don't have the right tool to get it out. What tool do I need? I don't have access. Look, if your plumber can't access the anode rod, it's just because they don't want to, all right? I get it. Sometimes a water heater would have to be drained, tilted over to access the anode rod. It's gonna take an extra 30 minutes. They don't want to do that. Doesn't matter, because when the water heater breaks and it leaks, they're going to come out and charge you to replace it, right? So who cares? All right, well, guess what? I care. I'm passionate about water heaters. I'm going to take this seriously, and I'm going to provide a very thorough service on all of your water heaters. So these water heaters are in service right now, and we're going to start with some of the easy checks that we can do to check our components. Let's start doing that. While we're doing this, we're going to get in here and we're going to check voltages to the elements in the water heaters. The power is on, so if you need to, you can disconnect the power to the water heater if you feel more comfortable. I've done this a few times. I leave the power on. I'm real careful with where I put my fingers. So I'm going to go ahead and access these elements with the power supplied to the water heater. Okay, so now we have this access. We've got upper thermostats. We've got our ECO. We've got our upper element. We've got our lower thermostat. We've got our lower element. The first thing I'm going to look at is I'm going to check the temperatures, and I'm going to see where they're set at. Okay, these are all set right at about 120 degrees. That's pretty standard. Your standard typical installation on your water heater is going to be a non-sequential water heater. When I say non-sequential, I mean you've got two elements. They don't fire at the same time. Okay, your lower one will be the workhorse of the system. It's going to come on and maintain the heat of the water heater. Okay, as the heat rises, it dissipates out through the top, the tank cools off, and the lower element will come on, heat back up, and then it continues that cycle. Water, when you run water, is brought in through a dip tube. Cold water is deposited down on the bottom of the tank. All right, when you do run water, this lower thermostat will say, hey, I need heat, kicks on that lower element. Upper element doesn't do a whole lot unless it's a brand new install. It's going to heat the top of the tank first, and then it's going to go ahead, and once this is satisfied, it's going to allow the lower thermostat to kick on that lower element, and then it'll heat the lower. Okay, then it's going to go into standby mode. So, okay, proper voltage. Let's check that. We are dealing with alternating current here. So we want to go to alternating current. We know that we're going to be dealing with 240 volts. On your rating plates, your water heater is going to tell you a lot of information. It'll give you the model, the serial number, production date. This varies by manufacturer. It'll also tell you the upper and lower elements and the combined. So you see the upper is 4,500, lower is 4,500. Total watts is 4,500. Why is it 4,500 and not 45 plus 45? Because it's non-sequential. Only one fires at each time. Therefore, the total watts at any time is 4,500. All right, so we're going to go ahead and turn our multimeter on to alternating current. Like I said, this is 240 volt system, so we're going to go ahead and set it up one step higher at 750. And let's see, we're going to test on the top. This is our incoming power. Okay, 248. That's good. Now, this is an ECO right here, electric cutoff, emergency cutoff. And if there's a problem, that will trip. It's like a breaker, and you can reset that if you need to. This one is not tripped. Okay, so we're just pushing that for demonstration. If this is tripped, you will not have power here. But we can see we have 248 volts. So we're good right here below the ECO on the thermostat. All right, do we have any power going to the lower element? No. All right, that tells us that do we have any power going to the upper element? No. I'm gonna show you something here though. Okay. I'm gonna take one lead and stick that on one side of the element, and I'm gonna test the other side to ground. And I'm gonna get 125 volts. Okay, now I'm gonna check the other screw on this element. So I'm gonna check this upper one where the yellow wire is. I'm gonna check that to ground. 125 volts. Don't let that fool you. That is not going to be sufficient to run that element. You're always gonna have one leg of 120 volts going to your element. Okay, this is the same here. If I check one of the leads up on the thermostat to ground, I get 124, and then I get 125, 124 on the other side. If I had a power problem and I put one lead on one side and one on the other, I wouldn't get anything. But here I'm getting a combined 240. That means that I have proper voltage to the heater, okay? If you can get 120 on each side, but you can't get it combined like that, you've got a problem. You've got a wire disconnected or a dead leg up on top. All right, we don't need to check the connections up on top of this heater because the connections come in and they run here, and this is their first point of contact inside of the heater, and it's good. So here up is good. We know that here down is also good. All right, so now what we want to do is we want to go down to the lower. All right, and we can check a couple of things. We can check to see if we've got at least some power coming down here. 120 volts, 120 volts, okay. 120 and 120. All right. Now, those two combined right there, giving me 240. All right, now what we want to do, let's see and make sure this. Okay, so even though this element has 120 volts going to it, it's not doing anything. This is a resistor element, and it's designed to work off 240 volts. All right, so right now this water heater is in standby mode. Neither element is supplying heat to the water. So what we want to do is run some water. Well, you can do two things. We can run some water, or we can turn the temperature up on the lower element to get this to kick on and to verify that we're getting proper voltage. So we don't want to waste any water right now and just run it for nothing. So we're going to crank it all the way up. And now we're going to see what happens. There we go. All right, we turned the temperature up. This thermostat said, hey, we need to get up to 150. Go ahead and kick that lower element on. And that's what it did. Voltage is good. All right, we're gonna go ahead and readjust this down to the temperature that it was set at, right about 120. We'll be good to go. Now we're gonna do the same thing up top. Okay, like I said, the upper element's not going to come on unless there's high demand, we've depleted all of the water out of the tank and it needs to get the upper part of the tank hot, or it's a new install. We've drained it, we've flushed it, and now it needs to heat up. So it's gonna do the top first, then go down to the bottom. Okay, upper element is not on. Okay. So what we can do, one of two things, we can run a bunch of water. We don't wanna do that. We're not gonna just waste water for the fun of it. We're gonna crank this up. Hear that click. There's bimetal plates inside of there that work off of the temperature, and they'll close that connection. So now we should have the upper element firing. Okay, and then once the upper element's done heating up, it will shut off and it will allow the lower element to turn on if it needs to, if it's calling for heat. All right, so we're gonna put that right at about 120. All right. Now, here's what we need to do next. And this is something that's just not done or understood. All right. This is a 4,500 watt element. This is a 4,500 watt element. Okay, it's 240 volt system. Again, on your rating plate, it'll tell you, it'll say a lot of things, like this one has 240 and then 208. So if you have 208 volts going to your house, there's no reason to call someone and ask if you can use that. If it's 240 to 208, it works. It derates the element. So from a 4,500 watts, say we're talking 208 volts, we're going to go down to 3380. Right? We're going to go with 4,500 watt element, and 4,500 divided by 240. All right, so 4,500 divided by 240 is 18.75. 18.75 is gonna be our amp draw. So when these things are cranked up, this element's going, we're gonna pull just shy of 20 amps, okay? So the breaker on this, when you look inside of your breaker panel, is gonna be somewhere in the 25 area, and that's gonna be pretty standard. Now what we're gonna do is, and I get plumbers that ask me this all the time, okay, to check to see if an element's good, we just simply disconnect the power, disconnect the wires, and we test the ohms, we test the resistance. And they don't know what it's supposed to be, okay? Or they may have tested a 4,500 watt element and they've gotten 12 or 13 and they say, well, that must be it. Then they start testing other things. People call me, hey, I'm testing an element and it's testing at 25 or 26 ohms. Certainly there's a problem, right? I don't know. What's the kW of the element? Oh, 2200 watt element? Yeah, that's about right. They got to do the math. Math is hard. They don't like to do it. It takes some time. So then we get stuck with people misdiagnosing things, changing out parts that they're not sure of. That's, just throwing parts at it. It's just not the way to do it, all right? So we know we've got 4,500 here. Let's go ahead and disconnect the power. And then we're gonna check the resistance on these elements, make sure they're good. And then we're gonna check the elements to make sure that they're not grounded. All right, this water heater has a nice quick disconnect, the way it should be. It may be hardwired into the wall. Without a quick disconnect, you can go to the breaker and turn it off. Or on this model, we can just simply pull that out, and there we have it. This water heater should now have no power. We are going to verify before we start touching wires. Okay, next part of the testing is going to be doing the resistance, so we want to make sure that we don't have power. So we're going to go back up to here. All right, no power, we're safe. We can now touch this, we don't have to worry about getting electrocuted. All right, test resistance. You've got 2 wires on your elements. We're going to disconnect those. And move those off to the side. And we're going to do the same thing at the lower element. All right, now let's see what we're going to expect here, okay? We've got 4,500 watt, and we're going to divide that by 240. So we know that this is going to pull 18.75 amps. And do our 240 divided by 18.75. and we get 12.8. That's going to be our expected resistance on this element, 12.8. Now, some multimeters are different. They may need to be calibrated. They're a little bit older. 12.8, if you're within a couple of points there, you're going to be okay. All right, you start to see stuff that's just way off the chart, you know you've got a problem. Set your multimeter to ohms. And go ahead and put your there. 13.2, 13.3. And like I said, what did I say? 12.8, we're at 13.2, we're good. This is good. Now let's test the upper. Okay, same deal, ohms. Got our wires disconnected. Try to get a good connection here. $13.4, 13.3. There we go. Good enough. All right. How do we check to see if our element is grounded? We're going to do this. We're going to put one lead on the screw here. All right. And then we're going to touch the outside of the element. This is where you would put your socket to take the element out of the water heater. So we're going to do that, and we're going to touch. All right, open. No connection. We're going to check the other screw. Open. No connection. All right, if we were getting a reading on there, that would tell me that that outer core of the, or the outer sleeve of the element has cracked. Water is getting inside of there to the filament, and it's allowing an electrical connection between there and the inside filament of the element. That element would need to be replaced. All right, so now we're going to check the lower one. Okay, same thing. We're going to go on one of our screws here. Okay, open. Go to the upper screw. Open. Good. So far everything. And this water heater is new. It's part of the concierge service. All of this service is included in here. But this water heater is new, so we're not likely to find a problem in there. But we will get an idea of what the anode rod looks like just after not quite a year, 10 months or so of operating the heater. All right, so let's continue with what we're going to do next. What we're going to do next is we're actually going to drain the water heater. Now, draining the water heater is done by shutting the power completely down, okay? And then you can put a hose on the drain valve right there and turn the water on, let some pressure flush out any debris that might be in there, and then we'll shut the water off, let some air inside of there, and then let this thing drain. A 50-gallon water heater might take 30-45 minutes to drain. 50-foot hose. If it's clogged up or you've got a longer hose, it may take even longer. Okay, we've got our garden hose connected. Water is still on, so still pressure on the tank. So what we're going to do is we're going to turn that on. And we're going to let that blow out any sediment or anything that's settled on the bottom. Just get some pressure, push that through. Make sure it's clear. That doesn't take very long. Like I said, this water heater is new. So one thing I want to add, these water heaters are new. We did not put these in. I did not put these in. These are retail water heaters. But to become part of the concierge plan, we have to vet them fully, so we've got to make sure that there are no deficiencies in the water heater. These plastic valves that are down on here are considered deficiencies. They become brittle and they leak a lot. They'll break off when you go to work on them if you need to remove these, and then they do leak. So to become part of the plan, we will be swapping these out to a full port brass ball valve. Like I said, we're going to be covering, you know, installation errors. We're going to be covering failures or leaks. Leaving a plastic valve on the bottom of a water heater would just be a great way to shoot ourselves in the foot, because we'd be getting calls on that. So those are going to be changed out with full port brass ball valve, but for right now we've got to use it to get the water out of the tank. Okay, we've got good flow. We're going to come back here to the incoming water and we're going to shut that off. Pull that lever down just like that. In this particular case, we're getting some back feed from the hot side. So what we're going to do is we're going to kill the the water inside of the house altogether. Okay, what we actually ended up doing was turning the incoming water off to each water heater, and that went ahead and stopped all water flow into the tank. There are vacuum breakers or air admittance valves up on the top of the water heater. So as the water drains, this is allowing air inside of there so the water can drain out and air can go inside of the tank. If you don't have an air admittance valve to drain the tank, you're going to need to open up a faucet or pop the temperature and pressure relief line. That temperature and pressure relief line is something that we are going to talk about here at the end of the video, so stay tuned for that. Right now we're going to be doing a waiting game. Once all of the water is emptied out of the tank, we're going to go ahead and inspect the bottom of the tank as well as the upper and lower elements. Okay, so this has been draining for a little bit over 30 minutes, so the water level is definitely down below this top element. And to speed things up, we're going to go ahead and look at this upper element. To do so, we're going to need an 1.5 inch 12-point socket. Okay. Now, got to be careful with these elements. Okay. Goes in and it curves back. If you start taking this thing out and you get this hung up, it's going to bend it. It's going to bend it so that it won't fit through the opening, and then you're going to be in a world of trouble. You're basically going to have to destroy this element to get it out. So, let's see here. Lots of buildup starting to form on this, okay? Like I said, this one's relatively new, maybe 10 months of operation, starting to get lots of gross buildup on the side of there. Now, on the side of this thing, and we can go ahead and clean that off, right? We can just take a rag, we can get that thing cleaned off, and we'll be back in business. Okay, like I said, this one's new, not very dirty, easy to clean off. I know what some of y'all are saying, I don't need to clean off my element, I'll just let it get dirty, and I'll pay the added expense from the inefficiency of the element. Cool story. This gentleman wants to have his cleaned and working properly, and that's what we're gonna do. For those of you that don't maintain your stuff, it's fine. But when you get online and you start calling people crooks and hacks because they do actually know how to maintain stuff and they do it properly and thorough, nobody cares. You know what they say about opinions, right? All right, nice and clean. Very good. All right, next thing to check, gasket. Check it to make sure it's not brittle. There's no pits, no cracks or anything like that. All right. When you start to get a gasket that becomes a little bit brittle, it's not elastic anymore, I'm gonna put a new one on there. probably going to be okay 1 or 2 seasons, then they're going to be replaced. All right, putting this back in there, reverse the process. Once that is in the tank, that long end of that, of course, pushes down from the leverage on there. It is a little bit hard to get it lined up. You just got to kind of use your fingers and the strength. Get it level. Start to get the threads to bite. And there you go. 1, 2, 3, 4. I was able to twist it 4 revolutions with my fingers. I know it's not cross-threaded. We're going to be good to go. We can tighten that back up. We will check for leaks, but the chance that leaks is going to be pretty minimal. 1.5 inch socket, repeat the process. Our element is installed. While we're waiting, we can go ahead and reconnect our wires. Okay, back in business up here. Element has been checked, gasket is good, element is nice and cleaned off. Now we're gonna wait for the rest of the water to drain out. We're gonna do the same thing on the bottom element. All right, our water level should be below the lower element. We're gonna check. If you loosen this and you start to see water dripping, if you're getting a little bit impatient, you know, water's dripping, you're just gonna have to tighten it back up and wait. We're good here, so we're gonna go ahead and take this out. Okay. Same thing. I'm gonna do an inspection on it. Lots of stuff kind of building up on it, not too bad. This house does have a water softener, which helps. So we're just gonna go ahead and get this element cleaned up. While you're cleaning it, of course, we'll check to make sure we don't see anything wrong on it. Anything that might be a cause for concern. As part of the plan, if we check an element and it does have something that's of concern, it'll be replaced. Okay, nice elastic gasket seal here, so we're good. All right, everything else looks okay. Again, same deal, you want to be careful when you're pulling your element out, not to get that hung up. That should be nice and even all the way through, so that looks good. And real quick, what I was talking about earlier, inside of this, of course, this is the outer copper. And if that cracks, water will seep in through there, and there's an insulator in there. And inside of the insulator is the filament, and that's the resistor. That's what gets hot. So it gets hot, heats up that insulator, and then the outer shell gets hot, and that's what heats up the water. You don't want water going inside of there into where the electrical energy is going through this thing. But that's what happens when it's grounded. That thing has cracked and water gets inside of there, and then they don't work properly. So that's why we do the test for element to ground. I was able to rotate that 3 or 4 times with my fingers. I know it's not cross-threaded. I'm gonna go ahead and tighten it back up. I apologize if all you're getting on camera is a picture of my butt. All right. Go ahead and hook our wires back up. A lot of times when you take these elements out and put them back in, once you tighten them up, they'll typically be in the same spot when they came out, so the wires won't be a problem. You don't have to mess around with them to try to get them back into the spot to tighten them up. You do, tighten this up real quick here. Get a little bit crazy there. Okay, so you do want to make sure that the wire is completely inserted on anytime you're doing electrical, right? And I'm not an electrician, and I know electricians out there that have told me before, when you're doing this stuff, make sure that it's completely inserted and you've got a good secure connection. A weak electrical connection, especially if it's it's just making partial contact, that'll get real hot. You'll start to get problems. I've seen these wires burn up, catch on fire. That's just dangerous, okay? So you want to make sure that whoever's doing this understands what they're doing and knows how to connect those and be safe about it. Okay, so we're good there. The water heater has been completely drained down. So this plastic valve will come out. We'll look inside of there, make sure that there aren't any problems, and put a full port valve in there, and then we'll be set from then on. That only has to be done once. Okay, now we're going to move up to the top of the water heater. One of the last things we're going to do is put the covers back on here. We're going to get this water heater filled up and pressurized after we're done checking the top, just to make sure we don't have any leaks. Once we check and make sure we don't have any leaks, we'll do the final assembly of the heater. Right now we're going to go up top and we're going to start looking at the temperature and pressure relief valve. Now, like I said, temperature and pressure relief valve presents excess pressure inside of the tank from building up to the point where the water heater will explode. It's happened several times. Like I said, search Phoenix, Arizona, watch that little news story. You can kind of see what the water heater does to the house. It wasn't pretty. The other one is the anode rod. Now, to get the anode rod out, sometimes it can be tricky. A lot of people cry baby about it. It's really not that hard. Accessibility can be a pain in the butt. I get that one. But trying to use an impact wrench with a 12-point socket, stripping out the anode rod and then telling the homeowner it won't come out, the water heater's ruined. This is just stuff that happens. And this is because someone who's not trained on how to properly do this stuff is out there doing it. Okay? I know a lot of plumbers that can go rough in a house on a new construction job and do it 15 times faster than I can do it, and then do it correctly. I don't do that. I'll do it wrong. Again, I'll put my skills up on the water heater repairs against anybody, and I'll get these right. You get someone that's out there that's been roughing in, and then they change positions or companies. Now all of a sudden they're doing water heaters. They don't get training. Someone mentioned this earlier about competency on the area of plumbing that they're working in. That is a real thing. Get a rough-in plumber, now he's servicing water heaters. He's never done it before. He's going to be calling tech support, wasting hours online trying to get them, Googling stuff. I see him go to Facebook and ask people how to fix stuff. And this is all on your dime. And then who knows if it's even getting done correctly. And the pictures that I look at and that I see, and the people that call me to look at, help do things properly after someone else has already done them, and say that there's a good chance a great deal of these jobs are not getting done properly. So, all right, let's move up top. Okay, here we are at the top of the water heater. Got our vacuum relief air admittance valve. That is working properly, looks good. Like I said, this is not that old, so we're not expecting a whole lot of problems. And we'll snap this back into place. There we go. Supply line looks good. Expansion tank, there's a bladder inside of there. Air charged. This top of this tank does need to be pumped up. so that you've got matching pressure, incoming water pressure about 85. You want to pump that up to about 85. That bladder does rupture inside of there, and then the whole tank fill up with water and it's not doing anything. It'll start to erode and then it'll leak. It's a big mess. So these things need to be inspected quite often. The traditional once a year inspection on these water heaters is just not working. I see it too often. A leak starts, and on month number 2, and then 10 months later it gets inspected, and now we've got damage galore and a lot of stuff that has to be replaced. Here's our TMP. We're going to test that here in a second. Okay, what we're going to do now is go after the anode rod. They are in there tight, and it helps to have some water inside of the tank to help hold the water heater in place as you put that torque on there. So we're going to go ahead and put some water inside, and we're going to let that fill up about 3/4 of the way, and that should help us. In the meantime, we're going to go ahead and pop this little cap off. We're going to access the inside of the tank area where we can get our tools onto the anode rod. Alright, so this cap comes off, and then there's the insulation here. It's a foam insulation, and you can just move that out of the way. Screwdriver, pick, needle nose pliers, whatever you want. Okay, once we feel like we've got a good amount of weight in there, we can shut that water back off. We're going to take this anode rod out. And what you don't want to happen is for water to, of course, blow up out of there as it's filling up. Okay, so we have our 1 1/16" 6-point socket. Don't use a 12-point socket. If you want to use an impact, you can. I find that they're a little bit too aggressive in some applications and can strip the anode rod out. So I like to use a socket. You got to make sure that that's seated on there. That insulation's down in there, and you can see it. It's just kind of crumbly. So you want to make sure you get enough of that out of there so that you can get a good, secure bite onto that anode rod. There you go. Takes a little bit of muscle. And you can get it to turn, and you're good. Okay, once it's loose, it's down inside of there. You may need some needle nose pliers to fish it up. Bring it up out of there. And here you go. Okay, so I want to show you something here. That's 10 months. Look how pitted and eaten away that is. It is doing its job. This is not going to go more than 24 months at all. Okay, and then just to give you some reference, here's a nice new anode rod. Nice and smooth, and then compared to this guy, look at that. Right?
So I can show this to those people that were explaining to me how water heaters don't need maintenance and we don't need to check that. And, you know, whatever. I'm not too sure those people even understand which end of their body they need to stick in the toilet in the morning when they use the restroom. But there it is right there. So this is going to go one more time. It's going to be replaced probably, we get quarterly inspections on this. And probably within the next 2 or 3 inspections, this is just going to go ahead and be replaced. But it does have a little bit of life left in it. Now, once this thing is completely gone, the water's going to start attacking the tank. Then the tank's going to leak. And then people are going to say, oh, I got to replace my water heater. And it's a lot of money. Okay. Well, not if you're a part of this plan. Okay. So we've got our Teflon tape all sealed up. And we're going to go right back inside of the water heater. And it is important to go ahead and get this threaded in there. You want to be able to thread it in there 2-3 revolutions at a minimum, just to make sure it's not cross-threaded. And I want to talk a little bit about cross-threaded anode rods. If you cross-thread an anode rod, the threads are not going to seal. It's going to leak. All right? So if your plumber comes to you and he says, I can't get the anode rod out, it's cross-threaded. All right. If that anode rod is sealed, came like that from the factory, and it's not leaking, your problem is not the anode rod, it is your technician. By the way, this water heater anode rod is part of maintenance. It's like brake pads. It's designed to wear out. So letting your anode rod wear completely out and then allowing the water to attack the tank should be a disqualification from warranty. So a lot of people call in and say my water heater is leaking, and they expect the manufacturer to warranty the water heater out even though they've done absolutely zero maintenance. And that's just laziness. It's dishonest. It's neglectful. I don't really roll that way. I know a lot of people do, but oh well. Just about there. And we're good. All right, 25 years of tightening up pipes on plumbing. I can tell when it's tight enough. I believe the spec is 60 foot-pounds. If you're German, the German torque spec is Guten tight. We can clean up our insulation up here. We can put our little cap back on. And then we're gonna be good. Now, here's what we're gonna do here. We're gonna turn the water back on. We're gonna fill this tank up. Before we do anything, remember when we're messing with draining the tank, we're gonna shut our power off, which we did. We drained the tank, we're filling it back up. Now, let's fill the tank back up. Open up this temperature and pressure relief valve. Like I said, if it hits 150 psi, this will relieve pressure. And if it hits 210 degrees, it will open. That'll, prevent the water heater from becoming a rocket. This needs to be checked. Like I said, concierge plan, we check them quarterly, at a minimum a year. But if you want to have some problem with your water heater and it goes unnoticed for 12 months, then fine, it's your house, you do what you want. We're going to check these more often. At the 3-year mark, these need to be changed out. So also, that's just another thing that nobody does. They look at it as unneeded maintenance until the water heater explodes, and then they rethink their life choices. So I'm not here to tell you what to do, but I can tell you what is beneficial for your home, especially because take this water heater for instance. Guess what's above it? Kids' bedrooms. So that might be a problem if we're not having safety in mind with these things. So once this fills up, water will come out through here, and then we can shut it off. And at that point, we know that we are good to turn the water back on. So I'm gonna get this cleaned up and then we'll meet back at the front of the water heater and check for leaks. Okay, water heater's full coming out of the TMP. We're gonna go ahead and shut that off. TMP looks good, no leaks. Water heater is full and we have no leaks. So no leaks, we can go ahead and put this back together. Thermostats are set at the proper temperature. So let's put this back together. Here's the tag. This is that tag off that temperature and pressure relief valve. These are mostly made by Watts. And anytime you get a temperature and pressure relief valve, this tag's on there. You can read on it. It'll tell you every 1 to 3 years to go ahead and replace these. Okay? And it's just something that's overlooked. A lot of plumbers don't even know that. They don't pay attention to it. Unfortunately, a lot of the plumbers just bypass proper diagnosis and they go right to the replacement. Now, I don't have a problem with plumbers that recommend replacements on old water heaters, but what I do have a problem with is the plumber that does not offer a repair. Okay, I don't know when I talk to you what might be best for you. You got to offer everything. I've got several different options of water heaters. Do you like any of them? Do you want a tankless? Do you want a high efficiency? Do you want a regular water heater? Do you just want it fixed? It's Christmas time. You want to get it through to the next quarter, tax return time, bonus time, then you can replace your water heater. That's fine, but we've got to offer all of those options. The plumbers that are coming out and just giving you replacement options and not telling you how to repair the water heater, or that it's not possible when in most cases it is, are being dishonest. Now, if the tank is leaking, yeah, you're pretty much done. If you've got components that need to be replaced, and maybe the anode rod needs to be replaced, the temperature and pressure relief valve needs to be replaced, you might not know what the right repair is. Now, in the concierge program, you don't have to worry about that. We're going to come out and check it. It needs to be replaced. It's replaced. You'll get a bill for it. It's included in your membership fees. But at least you're getting those offers to do the repairs. And if you're not on any type of plan, you're just paying for it out of pocket, you can add that up and say, well, listen, hey, the repair is going to be $800, $1,000, $1,200. I don't know what it is. You can weigh that against a new water heater with a warranty and a higher efficiency, and then you can make that decision. But you as a homeowner should be getting all of those options laid out on the table so that you can pick. Okay, we're gonna wrap this up. Water heaters are full of water, no leaks. Everything's been done that we need to do. We're gonna go ahead and power this back on. All right. What we're gonna do is, this is full of cold water. The upper element should come on. Okay, 2 ways to do it. One, if you're trained or you're used to this or you're professional, you can put your ear to it. I can clearly hear that upper element has fired. The other thing to do, of course, is put your multimeter back on there and check the power. But here's the fun one, and here's where I like to get a lot of these plumbers, and you may have experience with this too. Put in a new water heater, and natural question is, how long is it going to take to get hot? And you're going to get some sort of an answer, and it's usually a guess. About an hour, because they don't know. That's what they think. Someone told them that, or they've plugged in a water heater before and about an hour later or so they had hot water. But was it completely satisfied? Was there 50 gallons of heated water up inside of there? No, they don't know this stuff. And this is exactly what I'm talking about with people that are dealing with these water heaters that don't understand how they work. and they can't give you honest answers. So I'm going to tell you how to figure this out right now. We've got 4,500 watt elements, non-sequential, right? One works at a time, and we're dealing with about a 60-degree rise. We want the water to get to 120. It's coming in at about 60 degrees. That's the data we need. Here's what we're going to do. So when this gentleman asks me, how long do I need to wait before that thing is hot, completely hot, I'm going to be able to give him an answer. All right. So what we're going to do is we're going to take 2.42 times our delta T, change in the water temperature. We want to go from 60 to 120. That's 60 degrees. 2.42 times 60. Okay. That equals 145.2. Remember that number. Now we're going to take our watts, 4,500 watts, divided by 145.2. 4,500 divided by 145.2 equals 30.99. So let's call that 31. That's our gallon per hour recovery. Call your plumber, ask him right now, figure that out. I can't get these guys to tell me how to test a thermocouple, thermopile, or what the difference even is, much less figure out gallons per hour recovery. We're going to go over this equation, which is different for gas appliances. Okay, so we've got 31, right? 31 gallons per hour. That's what 4,500 watts is going to do to that water. We're going to take our capacity. We're going to divide it by our recovery rate. 50 divided by 31, 1.6. 1.6 hours for this to go from cold to hot, or from 60 degrees to 120, which is what we're talking about here. If we're talking about 80 degrees to 120, it's shorter. If we're talking about 40 degrees to 120, it's longer. Okay, you got to know your delta T, your rise in temperature. So when he says, how long is it going to take to get 1.6 hours? That's it. Boom, we're done. All right, this water heater's set. It's inspected first quarter 2024, second quarter 2024. It's going to be done again. We're going to look, try to find any deficiencies. Of course, it's covered. It's going to be fixed. We find any leaks, we'll fix it. They don't have to worry about their garage getting flooded. Have a great day. I hope the video was interesting. If you have any questions, let me know.